In this section of the bridging videos, we're going to look at something called coordinate geometry, which is kind of fancy for graphing straight lines. Well, initially graphing straight lines, it branches off a little as we go. But what you need to be able to do is get a complete grip of straight line equations. Now, a straight line equation is generally given in the form of y is equal to mx plus c, where m is the gradient and the c is the y-intercept. Okay, so this is the y-intercept. So we often call this the constant. Now what we're going to do is have a look at some of these. I've made a little gizmo here. This line that you can see on here is the line y equals 2x plus 0. This right here is a positive gradient of 2, which means that it's going up 1, 2 for every one it's going across. It's going up 1, 2 every one it's going across. This 0 corresponds to where it cuts the y-axis. So we'd write this as y is equal to 2x plus 0. If we increase, and this is on a decimal form, if we increase the c value here to 1, we're going to cut the y-axis at 1. If we increase it now up to 2, we're crossing at 2. We have the same gradient. I can change the gradient. I make it a steeper line. It's now going up 1, 2, 3 for every one it goes across. And if you want to read a gradient, then you can pick a point on here and read up. So it goes up 3 across 1. Gradient of 4, steeper gradient. Y-intercept of 2. Y is equal to 4x plus 2 in the form y equals mx plus c. If we change that gradient, if we change the y-intercept down to, if I can make it stop, to negative 4, we're now crossing at the point where x is minus 4. Now quite nicely, you can solve these equations by simply setting y to be equal to 0, and you can find a value of x. If you set y equal to 0, then 0 equals 4x minus 4, 4x equals 4, and x equals 1, which we can see just there. So this is a positive gradient now that we've got, and we've now got a positive y-intercept. A positive gradient will come from what we call the third quadrant, which is just here. It will come up through the third quadrant and it will leave through the first quadrant. This is the first, the second, the third, the fourth. Okay. This is the obligatory one they like to use. Y equals x. So for every y, the same x. 2x, 2y, and it just keeps going. Y equals x, we would just see that as y equals x. Now we're going to go to a 0 gradient, which just means a flat line. So that's the line there, if I can make it stop, y equals 1. This is the line y equals 2, and so on and so forth. Y equals 3, y equals 4, y equals negative 2, which is stuff you would have done hopefully at primary school. And in the same way, vertical lines, x is going to equal whatever. Let's now look at a negative gradient. This is a negative gradient of minus 1. We start in the second quadrant and leave in the fourth. So this is y equals minus x, y equals minus x plus 1, y equals minus x plus 2. And this is the form we write it in. So those are an absolute essential. You need to have a complete command on that, and I'll assume that the majority of you have prior to this. Now let's look at some work concerning these. Apologies that this is not on the screen. We're asked to write down the gradient and the y-intercept of each line. These should be fairly evident. The gradient is 4. The y-intercept is negative 1. So if we sketch this up, it would be a steep curve and it would be cutting at negative 1. It would look something like that, with this point being 0, negative 1. This one has a flatter gradient. It's 1/3 and it's crossing at the point where x is going to be 3. So it's 0, 3. This one, be careful, we can rewrite this in the form y equals minus x plus 6. This has got a negative gradient of negative 1 and it cuts at the 6, so it's going to be 0, 6. Negative gradient of 2, negative y-intercept of minus 3/5. So we're going to be somewhere down here, like so. You have to spot these in their form. We're asked to find the gradient and the y-intercept of each of these lines. Okay. What we need to do is put them in the form y equals mx plus c. So y is equal to mx plus c. We can evaluate the gradient far easier that way. So let's isolate y on here. So y is going to equal, subtracting 3 from both sides, subtracting x, will be minus x minus 3. So now we can see we've got a gradient of -1 and a y-intercept of -3. This one right here, if I take the 2y to the other side, then what we've got is 2y is equal to x minus 6. Doesn't matter that it's written that way round. We could rewrite this as 2y is equal to x minus 6. Divide throughout by 2, we want 1y. We're going to have 1/2 x minus 3. Gradient of 1/2, y-intercept of -3. This one here, we're going to leave the 3y this side, subtract 3x from both sides, add 2 to both sides, and divide by 3. Y is equal to minus x plus 2/3. Gradient of -1, y-intercept of 2/3. Okay, find in the form y equals mx plus c the equation of a straight line given gradient it passes through. Okay, now we're going to look at this the first time. We're going to look at it using y is equal to mx plus c. I personally don't. I prefer the next method we're going to look at. All we've got to do now is just put this here. If the gradient is 3, we can write the following and we can solve for c. So we can write the y-coordinate. 2 is equal to the gradient, which is m. M is the gradient, and then x. The point x is 1. So 2 is equal to 3 plus c, subtracting 3 from both sides, minus 1 is equal to c. So we can write this line as y is equal to mx plus c, with c being minus 1, and our m, obviously, which I could have put in on that go, is going to be 3x minus 1. So that is the equation of a straight line through those points. Gradient of -1 through the point 5, 3. Y is equal to mx plus c. 3 is the y-coordinate, minus 1 is the mx, so we get minus is equal to -5 plus c. Add 5 to both sides, 8 is equal to c, so y is equal to minus x, remember the gradient is -1, plus 8. So that is finding in the form y equals mx plus c, the gradient. First we've got a gradient, and this is the equation of a straight line. And again, that should be fairly straightforward, and it's an absolute must. Okay, let's move it on. Right, let's just go back actually. What I'm going to look at is something slightly different. I'm going to present the idea of another way of looking at this. We can write the gradient, the equation of a straight line as y minus y1 is equal to m, the quantity x minus x1. So let's take this first example. The gradient is 3 and it goes through the point 1, 2. So we can write y minus the y-coordinate of 2 is equal to the gradient 3 multiplied by x minus the x-coordinate of 1. So we could write this now as y is equal to 3x minus 3, and then of course we're going to be plusing the 2 to both sides, so we're going to end up with minus 3 and then plus 2, so y is equal to 3x minus 1. And you'll see that gives us exactly the same form as we did before, y equals 3x minus 1. I prefer this method. So for example, if we had this one here, which we did as well, y minus 3 is equal to minus, and we can just leave this as it is, minus 1 if you want to put it in, although generally with algebra it's not required. Minus, that's a gradient, and then we're going to have x minus 5. So what we'd have now is the following. We'd have on here, y is going to be equal to minus x, then we're going to have plus 5 and plus another 3, which is going to give us 8. So y is equal to minus x plus 8, or y is equal to 8 minus x. Either of those two forms is perfectly suitable. So if we look back, minus x plus 8 or 8 minus x. That is one way of writing the equation of a straight line. You may also be asked to put it in the form of ax plus by plus c is equal to 0. So for example, if I had the straight line equation where we've got y is equal to 2/3 x minus 4, and I was asked to put it in this form, what I need to do is collect it all on one side, set one side equal to 0, and generally have a, b and c as integers. So if I multiply the whole thing by 3, I'll have 3y is equal to 2x minus 12. Bring in the 3y over and set in the left hand side to 0, 2x minus 3y minus 12, and that's equal to 0. So all of these are integers where a is equal to 2, b is equal to negative 3, and c is equal to negative 12. That's the form ax plus by is equal to c, rather than this form, which is y is equal to mx plus c. And we'll look at that as we go on. Okay, we don't want those yet. What do we want? Okay, don't want those yet. Right, okay, we'll find the ones that I do want. They're somewhere kicking around here. Okay, let's go back. I've put them somewhere. No, I haven't. Okay, we'll look at them anyway. Okay, I've got some examples up. We must be able to find the equation of a straight line given two sets of coordinates that it goes through. So let's have a look now. We're asked to find in the form y equals mx plus c the equation of a straight line passing through each pair of the points. Now the way we do this is as follows, and there are loads of different ways you can look at this. Firstly, we need a gradient. We need an m value. And the m value is seen as y1 minus y2 over x1 minus x2, or you may even see y2 minus y1 over x1 minus x2. All you're doing on this is simply subtracting away one of the y coordinates from the other and then the corresponding x coordinate from the other. So let's do this then. Let's get a gradient. 13 minus 1. That is the change in y. 13 minus 1 over 4 minus 0. This is the change in y over the change in x, or delta x, or delta y by delta x, or you might hear it being called rise over run. So let's simplify this. 13 minus 1 is 12. 12 over 4 is equal to 3. So the gradient of this line is going to be 3. M is equal to 3. We've got 2 points that it goes through, and these are the easiest ones to deal with, 0, 1. So we want this in the form y equals mx plus c. So our two choices, we can do y minus y1 is equal to m, the gradient, x minus x1. Or we can do y equals mx plus c, and I'll do them both. There's no advantage. I prefer this method. So let's do it then. Y minus y1. Y minus 1 is equal to m, the gradient, x minus 0, which is the x coordinate. So you can see this is going to be y is equal to 3x plus 1. Let's do it the other way. Let's sub in the values. 1 is equal to 3 lots of 0 plus c. So we can see that c is 1. And then we can put y is equal to 3x plus 1. So either way, you must be able to get the equation of a straight line given 2 points. Simply subtract away the y coordinates. And so for example on this one I could do 9 minus minus 1, 2 minus 7. What I can't do is 9 minus minus 1 and 7 minus 2. You must, if you start with this bracket, you must continue. Hence for y1 minus y2, x1 minus x2. So 8 minus minus 2 over 2 minus minus a half. Minus 5 minus minus 2 over 18 minus 3. Or the other way around. Minus 2 minus minus 5, 3 minus 18. So that's in the form y equals mx plus c, just here. Okay, find in the form ax plus by plus c equals 0, where a, b and c are integers, the equation of a straight line that passes through each point. So again, let's take the easy one. The change in y over the change in x, that is the gradient. So change in y, y1 minus y2 over x1 minus x2. So the gradient is going to equal now 2 minus 0 over 5 minus 3. So what you can see here is that the m value is going to be 2 over 2, which is going to be equal to 1. So we need to set up the straight line equation. So y minus y1 is equal to m, the gradient, x minus x1. So let's pick the points, easy ones. I like starting with this because we got a naught. Y minus naught is equal to 1, which is a gradient which we don't need to write, x minus 3. So what we can see, y is going to equal x minus 3. In the form ax plus by plus c equals 0, we need to set this side to 0. 0 is going to equal x minus y minus 3. So the value of a is going to be 1, the value of b is going to be minus 1, and the value of c is going to be minus 3. Ax plus by plus c is equal to 0. If you wanted to use your y equals mx plus c, you're welcome to do that. So there we go, that's passing through some points. Okay, we're just going back where we were, and I've got a couple, right, here we go. Midpoint. The midpoint now is the following: x1 plus x2 over 2, comma, y1 plus y2 over 2. That's glorified. We don't need that. All we need to find the midpoint of a line segment is simply add the x's together, so 8 plus 0, and put it over 2, and add the y's together, 2 plus 4 over 2. So we can see that's going to be 4, and this is going to end up being 3. So the midpoint of that line is 4, 3. Okay, some of them get a bit more tricky, but it's simple arithmetic. Let's do this one. 1 plus 2 is 3. 0 plus 9 is 9. So we end up now leaving them in exact form. We get 3 over 2 plus 9 over 2. I think we got one more thing to look at. Here we go. Find the exact length. Now, the length between 2 points is glorified Pythagoras. Okay, if you think of some points now on a Cartesian, and this is what we call it, a Cartesian axis, and we have the following. What we've got here is 1, 1. We'll do the first one. 1, 1, and then 4, 5. If you look at what's happened, all we've got is a right angle triangle. That's all it is, it's a right angle triangle. So what you can see from here is that this distance, 1 to 4, on the x's is going to be 3. And then on this one, it's gone up by 4. And you know Pythagoras, a squared plus b squared equals c squared. So that's going to be 5. 9 plus 16 is 25, square rooted is 5. The distance formula in general is given d is equal to the square root of x minus x1, or x1 minus x2, or x2 minus x1, depending on which book you read, all squared, plus y2 minus y1 all squared. It's Pythagoras. Don't worry yourself over it. So let's choose these points. We will do the distance and work out which is, because these are what we call the absolute value, so it's never going to be negative. 4 minus 1 all squared plus 5 minus 1. Again, I'm being consistent on which is going first, all squared. So the distance is going to be equal to the square root. 3 squared is 9 plus 4 squared is 16. So the distance is the square root of 25, and the distance, quite funnily enough, is 5 units. And generally we work in units, so it'd be 5 units. On something like this one, for example, what we could do is the following. We could do the square root of 3 minus 1, which is going to give us 2 squared, and then 12 minus 7, which is going to give me plus 5 squared. So we end up with the square root of 4 plus 25, and we leave this in exact form as root 29. Okay, so 3 minus 1 is 2, 2 squared is 4, 12 minus 7 is 5, 5 squared is 25, 25 and 4, 29, root 29. So that's a basic intro to the equation of a straight line. You need to be confident with all of that stuff. This is starting to dip into AS, but it's something that you should be comfortable with. In the next video, we'll look at parallel and perpendicular lines.